Okay, we should be live. Hi, if you guys just jumped on, we're going to give everybody a minute or two to get on, and then we'll get started. We are not just going to go through your review sheet. I have all new questions, so that is something, if you're watching this later, if you want to grab scrap paper and work on this with me, that's fine. And send questions as you're watching tonight, guys. That's the whole goal, is that you can watch it live and get some questions answered. So we'll give people like a minute to get on, and we'll get started if my laptop doesn't fall over. All right. Are we frozen? Okay, we're gonna get started in like 30 seconds. So let me peel my clementine. When we finish that, we'll get started. Hi, if you just jumped on. And if you have questions, send them at any time. Just shoot them to me on Remind, even if it's before we start, and I can respond as soon as we get going. Okay. Hi, if you guys are on. If you're watching this later, also hi. Thank you for watching. If you're watching this later, feel free to pause, fast forward, whatever you need. If you're watching this live, use this opportunity. Send me questions. Use Remind, right? The goal of this is that you guys are getting your questions answered. So we are going to get started with a couple reminders, and then I'm going to go through some of the types of questions that you guys asked about today. So the first thing I want to remind you guys is that on your stamp sheet, you have these learning targets. And so on your stamp sheet, you literally have a list of things that you need to be able to do. So as you're studying, go through and do these. Can you graph radical functions? Can you identify transformations? Can you apply average rate of change? Go through and look at all of those things. And if you can do them, check them off. And if you can't, that's what you know that you need to be asking about. So that's something to keep in mind. We're going to run through the major topics tonight. If you have questions, send them my way, and we are going to get started. So, starting with simplifying radicals. That's the big first topic that we look at. So before we get too far into this, I want to look at the parts of a radical. And this is from your notes, but let's just make sure that we're clear on this. So this symbol, this actual symbol, is called a radical symbol, right? And the thing underneath that is called the radicand. So this is the number that's underneath that. Any number out front is just a coefficient. So that's just something that we are multiplying by. And then this little number up here, and notice it's sitting right on top of the radical. So it needs to not look like a coefficient. That number is called the index. And that's going to be a really important number as we look through both simplifying radicals and then actually changing them into exponents. It's also important to remember that if an index is not written, there's automatically a 2 out there. So a square root, assume you have an index of 2. So we've simplified a lot of square roots this year, but we're going to look at some more advanced ones. So I'm going to start with, let's look at this cube root here. So this cube root is cube root of 192, x to the 7th, y, z to the 12th. And so what I'm looking for here is to find groups of 3 because my index is 3. And so I'm looking for groups of 3 in any of these different types of numbers we're going to deal with. So I'm going to start with the 192, and I'm going to make a factor tree for that. So 192, well, I know that's even, so it's divisible by 2. So 192 divided by 2 is 96. And again, you can do any combination here, but I also know that's even. So I can do 2 and 48. And then you can get a little more creative if you want to. You can do 6 and 8 here. You can do, let's see, 2 and 24. And then we can keep going from there. So this would be what, 6 and 4. That would be 2 and 3 and 2 and 2. So my prime factors, I'm highlighting here, right? And so to write that 192, I'm going to be writing that as still a cube root. Notice my index is 3. But I'm going to put all of these together. So 2, 2, 2, 2, 2, 2. 3. And then x to the 7th, y to the 1st, z to the 12th. And you can write those all out, but many of you guys have started to see sort of what the patterns are with these and not need to write them all the way out. So with this, I'm looking for groups of 3 because my index is 3. So I have 3 2s and 3 2s. I've got 2 groups of 3, right? So I can take out 2 to the 2nd because there's 2 groups of 2. And then that 3 doesn't have any other 3's to take out, so leave it. X to the 7th, I can take out 2 groups of 3. Y, I can't take out any. Z, I can take out 4 groups of 3, right? And then what's left under the radical? So there's still this 3 left. I took out 2 groups of 3 for the x's, but there would still be 1 x left. There's still a y to the 1st left. And there are no z's because I took out 4 groups of 3. So the z's are all moved to the front. So this is going to be 4 x squared z to the 4th and then cubed root of 3xy. Okay, let's look at the next one. And again, if you guys have questions, just send them to me as we're working. You're on a little bit of a delay from me, so it might take a minute to go through. So let's look at this one, number 1 on here. And what I want you guys to notice on this one is that we are taking, let me just shrink this down. Okay, we are taking the 4th root and it's of a negative. So what we're looking at here is that we're taking an even root of a negative. So I can't just pull that negative out to the front. This will actually be imaginary because, right, the square root of -1 is imaginary. The 4th root of -1 is imaginary. So this negative is just going to stay out front, and then I'm going to pull that out to the front as an I. And so now I've got the 4th root of 40a squared b to the 8th. So 40 is going to be 2 times 2 times 2 times 5. A squared is a times a, b to the 8th. And again, you don't have to write this out, but for some people it's helpful to write it. And we're looking for groups of 4 since my index is 4. So I have the -I, right? There's no group of 4 here. There's no group of 4 here. There's 2 groups of 4 in the b, so I can take out a b squared. And so that's going to leave me with the 4th root of, this is still 40, and that's still a squared. So this would be my simplified answer. So the big thing to remember with simplifying radicals is your index tells you what you're looking for as far as groups. Okay, now converting between exponent and radical form. So these come up on the Regents a lot, and I would expect to see something where you sort of need to do some explaining. So explain what a rational exponent, rational meaning like fraction, exponent, that's an exponent, such as 5/2 means, and then use this to evaluate 9 to the 5/2. So remember what we talked about with the 5/2. That means, right, an exponent of 5/2 means to raise the base to the 5th and take a square root or a second root, right? So if we actually want to evaluate that, we would be doing 9 to the 5th and then taking a square root. Or you could be taking the square root of 9 and then raising that to the 5th. You can do either one, but you should be showing that work. And so I actually think this way is a lot easier, so I'm going to do that way. So the square root of 9 is 3. What is 3 to the 5th? That's 243. Okay, the next one, explain why 81 to the 3/4 equals 27. Now again, here you could put it in your calculator and get an answer, but like that's not explaining why. So you need to remember what the 3/4 power mean. So 81 raised to the 3/4 means take the 4th root of 81 and raise it to the 3rd power, right? So it really means take the 4th root of 81, raise that to the third. The fourth root of 81 is 3 to the third, and that is 27. But remember that if you see the word explain, that means you need to use words, right? So if you see explain, you need to write me a sentence or two. Okay, let's do a couple where we just practice converting here. So I've got this expression, the fourth root of 16x squared y to the 7th, and I want to convert. Now, if it just said simplify the radical, or if the answer choices were simplified radicals, we could do that. But notice that our answer choices are not simplified radicals, right? So I'm going to start by saying, okay, a fourth root would be the same as taking this and raising it to the 1/4, right? So fourth root is the same as 1/4 power. So I'm going to raise each of these to the 1/4. And remember, 16 to the first there, we're still going to raise to that power. So this will be 16 to the 1/4, x to the 2/4, y to the 7/4, because remember, a power to a power, you multiply. And then we can evaluate this. 16 to the 1/4, you can put in your calculator, or the fourth root of 16 is 2. And then we've got x to the 2/4 and y to the 7/4. And so that is answer choice 1. Now, very similarly, if we have one like this, x to the negative 2/5 is equivalent to what? So first of all, think about what negative exponents do. Negative exponents take your base and flip it. So this would become 1 over x to the 2/5, right? And that is going to be equivalent to, notice these are all in radical form, these answers. So power over root, so fifth root and second power. So that's going to be answer choice 4. Okay, let's do some properties of exponents, because this was something in class people had a lot more questions on. So 3 laws of exponents you need to know. When you are multiplying like bases, you add your exponents. When you divide like bases, you subtract your exponents. And when you raise a power to another power, you multiply. Those are the 3 we know. Those are what we're going to work with. So let's start basic, easy, and then we'll go from there. So this first one, I've got n to the 4th to the 3/2. That is raising a power to a power, so I'm going to multiply those. So this is going to be n to the, multiply these together. 4 times 3/2 is 12/2, which is 6. Now, same thing even if they're both fractions. Here you've got a to the 1/2 to the 3/2. Power to a power, you multiply. So this would be a to the 3/4. Let's get a little more interesting. So let's look at this one. So I'm multiplying all of these together, and we're going to deal with the numbers, and then we'll deal with the m's. So the numbers, I've got 2 times 4 times 4. That is 32. And then the m's, notice they all have the same base, so I can add my exponents. So I'm doing m to the second, m to the 3/2, and m to the negative second. So I'm doing 2 plus 3/2 plus negative 2. And that's going to be 32 m to the 3/2. And don't forget that you have a calculator and you can add on your calculator. Just use alpha y equals to get your fraction bar. Okay, let's look at another one. So number 5, again, we're going to deal with the numbers, and then we're going to deal with the variables. So the numbers, I've got 2/4. That's just going to be 1/2. And then the variables, I'm dividing, so I'm going to subtract. So it's going to be negative 7/4 minus 4/3. Now you can just put that in your calculator, or you can get a common denominator, which here would be 12. So this would be negative 21/12 and minus 16/12. So that's going to be x to the negative 37/12. And remember, typically we don't want negative exponents staying, so this would be 1/2, and then the x will flip down, x to the 37/12. Now let's look at some where we put this all together. So if I look at one like 6, right, I'm doing the whole shebang here. So I'm going to start in my numerator because there's a lot to do up there, and then we'll work between the numerator and denominator. So in the numerator, I'm going to do 3 times 3, which is 9. And then I have like bases on the x's, so that's x to the negative 1/2 and x to the 1/2. I am multiplying those, so I'm going to add them. Negative 1/2 plus 1/2 is 0, so that's x to the 0. Y to the negative 1/3. my denominator is just 3y to the negative 7/4. And so notice x to the 0, that's just going to equal 1 because anything to the 0 is 1. And now let's keep going. So 9 divided by 3 is 3. And now with these, I'm dividing, so I'm going to subtract. So negative 1/3 minus negative 7/4. Again, my common denominator there is 12. So this is negative 4/12 plus, because we're doing minus a negative, 21/12. And so that's going to come out to be 17/12. Yeah, y to the 17/12. And it's already a positive exponent, so leave it alone. And again, we're always just going back to which of those laws of exponents am I using. All right, last one we're going to do is this one. So I've got tons of stuff going on here. And you can start by simplifying within this. So you can subtract those exponents, subtract those exponents. We did a lot of that in class today, so I'm just going to do this one the other way in case that's how you normally do it. So if you're going to raise all this to the second, you need to raise each power to the second. So x to the 1/2 to the second, multiply those, that'll be x to the first. Y to the negative 2 to the second would be y to the negative 4th. Then this is y to the first down here, so that's going to be y to the second, power to a power. And this is x to the negative 7/4, so that's going to become x to the negative 14/4, or negative 7/2. Right? Power to a power and multiply. Now from here, you can divide, subtract, right? So for the x's, I'm going to do 1 minus negative 7/2. And so that's going to be 2/2 plus 7/2. So that's going to be 9/2. For the y's, I'm going to do negative 4 minus 2, so y to the negative 6. And then we don't want to leave negative exponents, so the x is going to stay in the numerator because that's a positive exponent. The y to the 6 will come down to the denominator. Okay, send questions as you guys have them. We're going to do one last thing with laws of exponents, and that is trying to prove algebraically whether something is true or false. So I've got the 10th root of x squared y over the square root of x squared y, and I'm seeing if that equals x to the 2/5, y to the 1/5. So let's check this out. I'm going to start on this side because it's more complicated, and I'm going to simplify. So here, this is to the 10th root, so it's going to be x to the 2/10, y to the 1/10. Over, because remember that's y to the first. This will be x to the 2/2, y to the 1/2. So that's going to give me x to the 1/5, y to the 1/10, over x to the first, y to the 1/2. And now we're dividing, so let's subtract our exponents. So that's going to give me x to the 1/5 minus 5/5 is negative 4/5. And then y, I've got 1/10 minus 1/2. So that is 1/10 minus 5/10. So that's negative 4/10. And so what I wind up with there is 1 over x to the 4/5, y to the 2/5. That does not equal this. And so I would say this is false. And remember, if it says prove algebraically, you've got to do algebra. You've got to actually do algebra to see if those are equal. Oh, my webcam fell. Okay, let's solve a couple radical equations. I'm going to grab a drink of water. If you guys have a question, send it to me because there's a bunch of people watching and you are awfully quiet. All right. So let's solve some radical equations. Remember, my goal with these is to get the radical alone. From there, then you can do the inverse or whatever you need to do. So this first one, the radical is already alone, right? And remember in class, we often would put like a rectangle around that. So once that radical is alone, then we can do the inverse operation. So I'm going to square each side. So 2x plus 1 equals 9. And then I get 2x equals 8. So x equals 4. Now remember, we are not done. You have to check. So to check this, plug back into the original. So that's going to be the square root of 9. Does that equal 3? Yes. So that's my solution. All right, next one. X to the 4/3 minus 16 equals 0. This is my sort of radical there. It's x to a fractional power. So I'm going to get that alone. So add 16. And that now that that's alone, you can rewrite it as a radical, or you can just raise both sides to the reciprocal power, right? This side's going to be x to the first. This side, we need to think carefully. So first of all, notice that we're taking a 4th root. That's an even index, so you need a plus or minus there. And then 16 to the 3/4 is going to equal 8. And that is because we are doing the 4th root of 16, which is 2, and then cubing it, which is 8. Now, we need to check these. Let's make sure that these check. So check. If I do 8 to the 4/3 minus 16, I do get 0. That works. If I do negative 8 to the 4/3, I get minus 16. I get 0, and that works. So I've got 2 solutions here. All right, next one. So I've got 2x minus 1 to the 2/3 plus 1 equals 129. This is my base and my exponent, so I need to get that alone. So I'm going to start by subtracting 1. And again, I want this alone, so I'm going to divide by 2. So x minus 1 to the 2/3 equals 64. Now I'm going to raise that to a reciprocal power, so 3 over 2. 3 over 2. These will cancel, so this is just x minus 1. 64, remember here we're taking a square root, so that's going to be plus or minus. And then 64 to the 3 over 2 is 512. And so plugging that back in, add the 1, x equals plus or minus 512. So this would give me x equals 513 or x equals negative 511. And then check those solutions, make sure they both check. If you plug them back in, and then you're good. Those are your solutions. All right, last one, and then we'll do some word problems. Looking at this one, this is my radical. That's what I want alone. So I'm going to add 1. Now that that's alone, I can square both sides. So 19 minus 3x equals, square out the right side using double distribution. So 9x squared plus 6x plus 1. Now, it's quadratic because we have that x squared, so let's get it to equal 0. So I'm going to add 3x and subtract 19. So 9x squared plus 9x plus, minus 18. And now let's factor. So you can take out a GCF of 9. And then you'd have x plus 2, x minus 1. And so that gives me x equals negative 2 or x equals positive 1. So we're going to plug those back in to check. So for the check, we're going to do square root of 19 plus 6, plugging in negative 2, minus 1. Does that equal negative 6? So square root of 25 is 5 minus 1. That does not equal negative 6. So reject that. Plug in 1, so square root of 19 minus 3, minus 1 equals 3. Does 4 minus 1 equal 3? That is true, so there's one solution there. Okay. All right, let's look at a word problem. Again, you're quiet. I know you guys are watching. I can see that. Send questions if you have them. All right, so here's a good word problem. Mrs. Stranda left a box of dog biscuits open on the table today when she went to work, and Harper's taking full advantage. The number of biscuits B remaining in the box after n minutes is given by this function. Determine algebraically how long it will take for there to be no biscuits left. So if we want there to be no biscuits left, that's a B value, right? That's a number of biscuits. And so I need to substitute in for B. No biscuits left would mean 0 biscuits, right? So I'm going to determine when this equals 0. So square root of m minus 1 minus m plus 7. Let's get our radical alone. So add m, subtract 7, right? Let's square both sides. So that would give me m squared minus 14m plus 49 equals m minus 1. And again, this is quadratic, so let's make it equal 0. So m squared minus 15m plus 50 equals 0. That factors to be m minus 5, m minus 10. Plug them both in. And let's plug them back in, let's plug back in to make sure they check. So if I plug in 5, it would be square root of 5 minus 1 minus 5 plus 7. And our goal is for that to equal 0. So this is square root of 4, which is 2, minus 5 plus 7. That does not equal 0, so 5 does not check. If we plug back in for 10, it would be square root of 10 minus 1 minus 10 plus 7 equals 0. So this would be 3 minus 10 plus 7, which does equal 0. So 10 minutes would be your answer. So these are all the same. It's just that when you're solving it, now you've got to figure out what to plug in, okay? Same thing for this one. So this one says the lateral surface area of a cone is given by this equation, where r is the radius, h is the height. So if we know the lateral surface area is this, so I'm going to plug that in where s is. And the radius is 5.75, so I'm going to plug that in for radius. And notice radius is in 2 spots, right? Then it says find the height. So now you would do the same thing and solve, right? Get this alone, square both sides, and go from there. Okay, last 2 major topics. If you guys are not sending questions, we're zooming through this tonight. So graphs. So these are your parent functions. You need to know what these graphs look like. But remember that you can always plug them in your calculator and look. So a square root function is going to start at 0, 0. It's going to go towards infinity. Its domain is 0 to infinity. Its range is 0 to infinity, right? A cube root function has a very different domain and range. So its domain is all real numbers. Its range is all real numbers, right? But you can always look at your calculator to see these. So let's think about some transformations. Remember with transformations, we have horizontal inside, vertical outside. So the graph is shown at right is a transformation of y equals cube root x. Which choice is the equation for this function? So cube root x normally looks like this. What I notice most is that the x-intercept is normally at 0. This x-intercept is not there. So notice normally it's up here. It's moved down. So that's a vertical shift. So the change should be outside since it's a vertical change. So I'm going to say it is not this one or this one because those are both inside changes. Now, vertical changes, remember those go directly the way you think they would. So if it went down 2, then it would be minus 2. The next one, this is a transformation of the square root function. Remember, square root function normally starts at 0, 0 and then goes right. So this got translated to the left because normally it would look like that. So this went left 4. That's a horizontal change, so it's going to be inside. So I know it's not these two. And remember, when you're inside the parentheses, it's going to go the opposite direction to the sign. So if we want to go left 4, that's going to be x plus 4. All right, last one, and this is really a reading question. So it says h is a transformation of f. How would you express h? So from f, this is my original, h is the transformation. So from F, I went down and I went left. So this would be down 4, left 2, right? So we want to go down 4, which all of those transformations do. But it also needs to go left 2. So it's not that one and it's not that one. Now left, I know that's moving in a negative direction. So in my parentheses, it should be a plus. And guys, remember with graphs, like you have a calculator. You can always look at your calculator, see what that graph looks like, and go from there. Okay, last topic, inverses. So people specifically requested that we talk about the graphs a little bit more, and then we'll find a couple inverses, and then I'll hang out for questions. So remember graphs of inverses, your x's and y's flip. So let's say that I wanted to find the inverse of this function, right? What I would tell you to do is put that in your calculator and look at the graph. So I'm actually just going to sketch it. So I know it's a square root function. This would go left 1 and down 3. So normally a square root would hit there. This is actually going to go left 1 and down 3 and then go like that. So the point -1, -3 should be on your original function. And you could look at the, plug it into your calculator and look at it. If this is on the original function, then the inverse of that should be on the inverse, right? So I'm looking for a radical equation that looks like it got flipped where -3, -1 is a point. And so these two are the ones that look like radical equations, right? And this one has -3, -1 as its starting point. So I'm going to match that one with A. Now the other radical one, we could do the same thing, and that would be D. And then these two you can match similarly. Look at the graphs, look at the table, find some points that are swapped. Okay, these are my last 2 questions planned, guys. So if you have questions, now's the time to send them. All right, I want to find the inverse of this. So the first thing inverse should make you think is switch x and y. So x equals 3, y minus 1 to the 4/5 minus 2. Now remember what we've been doing all along is we've been saying we need to get that exponent part alone because we need to solve for y. So I'm going to add 2. And then I'm going to divide by 3. Now that that's alone, I can raise this to the reciprocal power. And whatever I do to one side, I do to the other. So this side's just going to be y minus 1. This side, we're going to do x plus 2 over 3 to the 5/4. But remember here, we're taking a 4th root, so you're going to need a plus or minus there. And so then add 1, so plus or minus x plus 2 over 3 to the 5/4 plus 1. Okay, this is the last one I have planned, guys. Send questions. So here I'm starting with f. So x equals the 5th root of y plus 4 minus 1. I am going to add 1. And then now I have the 5th root alone, so I'm going to raise both sides to the 5th. So that gives me x plus 1 to the 5th equals y plus 4. Solve for y. Oh, minus 4, sorry. And notice on this one I started with f. This is a function. It's just a quintic function raised to the 5th. So instead of y, I'm going to make that f inverse of x equals x plus 1 to the 5th minus 4. All right, guys, that is all I have planned for tonight. I'm going to hang out basically until I see the numbers dwindle. If you have a question, now is the time to ask it. And I will be after school tomorrow, as long as we are in school. And otherwise, even if you're not watching this live, feel free to send me questions. That's totally fine. You can do that at any time. Oh, that was a bad clementine. This is not good. Ugh. Okay. Any questions? All right, guys, the numbers are dwindling. Nobody's asking questions, and I need to go throw this clementine in the trash. So, I hope you guys have a great night. Send me questions as you're studying. You're going to do awesome. And I will see you guys on Friday.